Hello everybody and welcome to this video. In today's video we're going to have some coding exercises with respect to the for loops in R. So why do we need to have for loops? For example, imagine that you would like to print 5 numbers from 1 to 5. So what you need to do is to write down print 1, for example, print 2, print 3, print 4, and print 5. Okay, this is what you need to do if you want to print numbers from 1 to 5. So you can do it manually for numbers from 1 to 5 because the range is so small, you can do it in less than 10 seconds probably. But if the size of this range increases and you would like to print numbers from 1 to 100, it does not take less than 10 seconds. It consumes a lot of time. Rather than doing things manually, you can use loops in order to have efficiency in writing your codes. So here, for example, in order to print numbers 1 to 5, I simply have a for loop. This is the keyword for declaration of a for loop. For each I here is my iterating variable. For each I that is in the range of 1 to 5. Okay, including 1 and including 5. So it's going to start from 1 and it's going to end at 5. For each I in this range, execute this part of the code. And this part of the code is basically printing this message, iteration, and then also prints the I. So when I run this code, we see these prints in the output. So iteration 1, iteration 2, iteration 3, iteration 4, and iteration 5. So in each iteration, I gets one value in this range. In the first iteration, I equals 1. In the second iteration, I equals 2. In the third iteration, I equals 3. And then 4, and then 5. So this is basically how we can print numbers from 1 to 5 simply using a for loop rather than doing things manually. As you see, it's easier to do it in 2 lines only. Then we would like to now learn how to loop through vector elements. So imagine that we are having a vector called fruits, and here my vector has these 3 elements: apple, banana, and cherry. And I would like to loop through the elements of this vector. In order to do that, what I do simply is to have a for loop for each fruit in the fruits vector. This fruit is my iterating variable. It can be I, for example. So I name it I, or I can name it, for example, X. Whatever you want, you can choose it yourself. So for each X that is in the fruits, in each iteration, do this part of the code. Print that element for me, and I would like it to be uppercase. So when I run this code, you see that we are having apple, banana, and cherry. So in the first iteration, X equals apple. So we are having the print of apple, and it's in uppercase because we are calling the toUpper function in order to uppercase our letters. Then in the second iteration, X equals banana. So we see banana here. And in the third iteration, X equals cherry, and we are printing X, which equals cherry, and we are printing cherry in the output. So this is also basically how we can loop through vector elements. And finally, if we want to loop with index and value, for example, here I can have for each I that is in the fruits, but before calling the fruits vector, I call the sekalong function. This is going to help me to have the indices as well. And then in the next line, I'm printing the value of I and also the ith element of that fruits vector. So let's see the output. It would be less abstract. Looking at the output, we see that in the first iteration, I equals apple. Okay. In the second iteration, I equals banana, and in the third iteration, I equals cherry. Okay. But when we are calling the ith element of the fruits vector, we see this, meaning that, for example, we are having the call of fruits with index, for example, 1, then the call of fruits with the indexed 2 and fruits with index 3. Okay, so when I, in the first iteration, I equals 1, and it is going to call the first element of the fruits vector, which is apple. Okay, this is what is being done here basically. So then I equals 2, we are having the second element of the fruits vector, which is banana, and we're calling the third element of the fruits vector, which is cherry. So this is why apple, banana, and cherry are being printed here on the right hand side, and on the left hand side we see 1, 2, and 3. So this is the value of I, 1, 2, and 3. So when I equals 1, 1 is being printed here, and then fruits for the first element is called, which is here. So the first element of the fruits vector is called, which is apple. Then I equals 2, the second element of the fruits is called, so banana is there, and I equals 3, then the third element of the fruits vector is called, which is cherry in the output. So in this video, we learned how to loop through a numeric range, how to loop through a vector element, and how to loop through a vector with index and value. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we're going to combine two concepts, loop and conditional statements. So we are going to have for loops, for example, and if conditions that are inside the for loop. So we would like to write a program that is going to print numbers from 1 to 10, and if we reach number 6, we would like to exit the program. Okay, so here is my for loop starting from 1 to 10. So I have for each I in the range 1 to 10, execute this part of the code. So we're going to do the for loop for this part of the code, and if this I equals 6, print this message, reached 6, stopping early, and then break. Break means that get out of the for loop. Okay, do nothing more. Okay, and in each iteration here, when I equals 1, for example, the first iteration, I equals 1. So 1 equals 6? No, because here in the first iteration, I equals 1, the starting point. Then we say, okay, I equals 1. 1 equals 6. This is the if condition. No, this part is not true. Therefore, this part of the code is not executed. Simply, we are going to print 1. Then I equals 2 in the second iteration. 2 equals 6. No, this part is not executed. We print 2. So we're going to continue up until 5. I equals 5. Then I equals 6. I equals 6. So 6 equals 6. Yes, this part is correct. When this part is correct, we are going to execute the blue part. We are going to show this message, reached 6, stopping early. You see? And then we are having the break statement there. So we see that after having the break, nothing happened. So we are having the reached 6, stopping early, and then we are breaking. So we are getting out of the for loop. Okay, so we are not printing 6, 7, 8, 9, and 10 anymore, because we are writing down the keyword break. When we write down the keyword break, the compilers understand, okay, now I need to execute, I need to get out of the for loop. I'm going to exit the for loop. Okay, this is the usefulness of the break statement. For example, when we reach a certain number, when we meet a specific condition, for example, in our code, we're going to put the break. Okay, we're going to tell the compiler, okay, if this condition is met, break, get out of the loop, and I don't want to continue anymore. So you see that this is why we're having the print from 1 to 5, and then we are having this message being printed, reached 6, stopping early, and then after that, right after that, we're having the break. So we're going to get out of the for loop. So this is why this part of the code is not executed anymore. Okay, so this is the example of the first example of a conditional statement with a for loop. Then we would like to learn about the next keyword. Now I would like to write a program to print numbers from 1 to 10, and if that I number is divided by 2 and the remainder of their division equals 0, it means that that number is an even number. Okay, and in that condition, execute the next keyword, meaning that I'm writing the next keyword, meaning that I'm telling the compiler skip this part. Okay, so in the first iteration, I equals 1. So 1 divided by 2, the remainder of their division equals 0? No. Therefore, this part of the code is not executed. We are having the print of message odd number, and then number 1 is being printed as you see here. In the next iteration, I equals 2. So 2 is divided by 2. The remainder of their division equals 0. Yes. So this part of the code is executed, which is going to implement or execute the next keyword, meaning that skip this part, this number. Do nothing with this part. Okay. So this part is not executed. It goes for the next iteration. So I equals 3 now. 3 divided by 2. The remainder of this division equals 0. No, this condition is not true. Therefore, this part of the code is not executed. So we have odd number, message, and then number 3 is being printed here. So you see here. And this loop is going to continue until we reach the I equals 10. So by putting this condition and the next keyword, what we are doing is that we are skipping the even numbers and we are only printing the odd numbers 1, 3, 5, 7, and 9. So this is also the usefulness of the next keyword. For example, if we reach a certain condition, if we meet a number, for example, in our for loop, we can simply write down the next keyword so the compiler understands that, okay, this is not desirable and we're not looking for this. Just skip this iteration. So in this video, we learned how to combine for loops and conditional statements, let's say control statements. And moreover, we learned how to use the break and next keywords. Thank you for watching. Hello everybody and welcome to this video. In today's video, we are going to learn about nested loops. Nested loops means that we are having a for loop inside another loop. Okay, so we are having one inner loop and one outer loop. So for example, now I would like to print the multiplication table like this one. So you see that here I have numbers from 1 to 3. So 1 multiplied by 1, 1 multiplied by 2, 1 multiplied by 3, 2 multiplied by 1, 2 multiplied by 2, 2 multiplied by 3, 3 multiplied by 1, 3 multiplied by 2, 3 multiplied by 3. And their corresponding result is being shown out there as well. So I would like to print something like this. Okay, for this I need a nested loop. So we are having the outer loop and the inner loop. So for each I in the range between 1 and 3, and for each j in the range between 1 and 3 as well, I'm going to print the value of I, and then this sign, which is this one, okay, the multiplication sign, then the value of j, then this equal sign, okay, and after that I'm going to print the I multiplied by j result. Okay, so in the first iteration, let me put it this way. First iteration, I equals 1, j equals 1. So we have the 1 multiplied by 1, so the output is 1. In the second iteration, I equals 1 still, but now j equals 2. Why? Because we are in the outer loop. So I equals 1, then j equals 1, j equals 2, j equals 3. Okay, when we reached the ending point for the j inner loop, we go up in the outer loop and we increment the value of I by 1 unit. So now I equals 2. Then again, j equals 1 to 3. Then again, I equals 3. And then again from 1 to 3 for j. So I equals 1, j equals 1, I equals 1, j equals 2. The result is 2. So we see that 1 multiplied by 2 is 2. Okay. So third iteration, we have I equals 1, j equals 3, so the result is 3 as you see here. So 1 multiplied by 3, the output is 3. Now we reached the ending point of the inner loop, which is j equals 3. So now we need to go up and increment the value of I. So in the fourth iteration, we have I equals 2 now. Again, j equals 1. So it starts from 1 more time, because now we are entering the inner loop with I equals 2. So j is going to take values from 1 to 3. So the result will be 2 multiplied by 1, it's 2, as you see here. Okay. Then we have the fifth iteration, I equals 2, j equals 2. Then we have the sixth iteration, I equals 2, j equals 3. So we see that I equals 2, j equals 2, I equals 2, j equals 3. And now that j equals 3, we go up, we increment the value of I. So now I equals 3, j equals 1, I equals 3, j equals 2, I equals 3, and j equals 3. And their corresponding result is being shown on the right hand side as well. So it is being calculated from this line I multiplied by j. So this is basically how we can have a multiplication table. For example, I can have the multiplication table of number 1. So let me run the code. Now I have the multiplication table of number 1. So 1 multiplied by 1, it's 1. 1 multiplied by 2, it's 2. 1 multiplied by 3, it's 3, up until the end, 1 multiplied by 10. This is basically how we can create a multiplication table using nested loops in R. Now I would like to do the pattern printing. Okay, so this is the pattern that I would like to be printed. So for this one also we need to have a nested loop. So we are having the outer loop, which is for each I in the range 1 to 5. So because I would like to have 5 rows. Okay, and in the inner loop is that for each j in the range between 1 to I. So the starting point is 1, but the ending point equals the value of I. Okay, so this way in the first iteration we are having I equals 1. Okay, then j equals 1 as well. And in this part, we're going to print 1 star. Okay, 1 star is being printed. You see here, 1 star is being printed. Then we are having this part of the code which helps us to go to the next row. So 1 star is being printed, and then we go for the next row. So in the second iteration, we have I equals 2. So j equals 1 and j equals 2. Okay. So when I equals 2, j equals 1, okay, because j starts from 1 and it continues up until 2. Why? Because in this iteration, I equals 2. So j can get values 1 and 2. So firstly, we are having this part of the code, I equals 2, j equals 1. So we are having the first star being printed because we are having it here. Then we are in the same outer loop, but we change the inner loop. So now I equals 2 and j equals 2 as well. So in this situation, we are going to also print 1 more star here. Okay, so this is why we are having 2 stars here. And then the inner loop is also finished. Then we go to the next line using this \n. So we are here now. So we go to the next line, starting point of the row 3. So now I equals 3. So in the next iteration, second and third, it was second and third iterations. Okay. So in the next iteration, I equals 3 and j could take values 1, 2, and 3. Why? So I equals 3 because it's the next iteration, but j can be 1, can be 2, and its ending point is the value of I, which is number 3, so it can also get the value 3 as well. And when I equals 3, j equals 1, we are going to print 1 star, which is here. When I equals 3, j equals 2, we are going to print another star, okay. When I equals 3 and j equals 3, we are going to print another star. So this is why in the third row, we are having 3 stars being printed in the output, okay. Basically, then the number of prints of a star that is out there depends on the number of the entrance in the inner loop, because whenever we enter the inner loop, the only thing that we are doing is that we are printing the stars, okay. And this is going to continue up until I equals 5, and j can get values from 1 to 5. So this is why in the last row we are having 5 stars being printed. So in this video, we learned about nested loops. We did a coding exercise regarding the multiplication table, and we did another coding exercise for pattern printing. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we're going to have a coding exercise with respect to while loops in R. So we're going to use while loops in the situation that we don't know how many repetitions we are going to have in advance. So this is why it is useful to use while loops in these conditions. So for example, here I have the variable called count, and it is initialized to be 1. Now what I would like to do, I would like to write down a while loop. So as long as this variable count is less than or equal to 5. So we're going to continue this loop as long as this count variable, which is number 1, initialized to be 1, is less than or equal to number 5. So in order to write down a while loop, simply we write down the keyword while, then inside parentheses, we are having the conditions. So my condition is to continue as long as count variable is less than or equal to 5. And when this condition is passed, this part of the code is being executed. Simply we are printing the value of count, and then we are incrementing its value by 1 unit. Okay, so now count equals 1. So while 1 is less than 5, is this condition is true? Is it true? 1 is less than 5? Yes. So print the value of 1. Okay, so print this message count, which is here, and then the value of the variable count, which is number 1, then increment its value by 1 unit. Okay, so now count equals 2. So we go and check the condition one more time. 2 is less than 5 now, yes. So print 2 and increment it by 1 unit. So it's now 3. So the count variable is now 3. 3, is it less than, we go for the next iteration. 3, is it less than 5? Yes, print 3, increment it to be 4. So we are printing 3 and increment it to be 4. Now count equals 4. 4, is it less than 5? Yes. So print 4 and increment it to be 5. So we print 4 and increment it to be 5 by 1 unit. So 5, is it less than or equal to 5? Yes. So print 5, we print 5 and increment it by 1 unit. So it's now 6, count equals 6. So now we go for the next iteration. We check the condition. 6, is it less than or equal to 5? No, this condition is not true. Therefore, we are not going to enter the while loop anymore. So this is why we are going to stop here. We are having the count being printed from 1 to 5 only. So this is how we can work with while loops. Thanks for watching. Hello everybody, and welcome to this video. In today's video, we would like to learn about for loops in R programming language. Imagine that I would like to print numbers from 1 to 5. In order to do that, first of all, the first thing that I could do is to print them one by one. So print 1, print 2, print 3, print 4, and finally print 5. So I need to write down the print function 5 times. So when I want to print numbers from 1 to 5, it's easy to write 5 lines of code. However, if we would like to print numbers from 1 to 1000, it would be very difficult to do it manually. This is in fact why we do coding in the first place. So this is why we need to use coding, and we need to develop a good code, an efficient code to do the work for us, instead of us going through a very difficult journey like writing the print function 1000 times. Okay, so now for repetitive tasks like this, so printing numbers from 1 to 5, we can use for loops, meaning that we're going to write 2 lines of code instead of writing it thousands of times to do the work for us. For example, here I would like to print numbers from 1 to 5. I would like to use a for loop, meaning that I would like to have a loop that is going to iteratively get numbers from 1 to 5, and in each iteration it is going to print the value of the taken unit. Okay, for example, here I write down for loop, so I use the for keyword, and in parentheses I define my iterating variable, which is I. So for each I in the range between 1 and 5, so go and execute this part. Okay, print I in each iteration. So in the first iteration, I equals 1 because the range starts from 1. It prints number 1. Then in the next iteration, I equals 2, it prints number 2. Then next iteration, I equals 3, it prints number 3. Next iteration, I equals 4, it prints number 4. And finally, in the last iteration, I equals 5, so it prints number 5 in the output as we see it here. So we see that by defining a for loop and writing down the print function only one time, we get to print the numbers that we are looking for. So instead of 1 to 5, what if I want to have 1 to 50? So for that, I simply change the ending point. Okay, and I run the code one more time here, and you see that from 1 to 50 is being printed here. Okay, so in order to do repetitive tasks, it's better to use for loops. For example, here I wanted to print numbers from 1 to 50, in this case, in the last example. So I use the for loop. I have my iterating variable for each I that is in the range 1 to 50. So before colon, it's the starting point. After colon, it's the ending point. Okay. And for each I that is getting these values, perform this. Okay, print I. And in each iteration, we print the value of I, and we see that it goes exactly from 1 to 50 that we were looking for. Thanks for watching. Hello everybody, and welcome to this video. Hello everybody, and welcome to this video. In today's video, we would like to print the square of each number from 1 to 5. So now that we see that we need to print the squares of numbers from 1 to 5, it means that we need to do a repetitive task. And a repetitive task requires a for loop. Okay. So in order to have a for loop, we simply write down the keyword for, and I is my iterating variable. So for each I in the range starting from 1 and ending at 5, because the problem statement was mentioning that, we're going to start from 1 and we're going to end at 5. Okay, we're going to execute this part of the code. For each I in this range, we're going to execute this part of the code. In the first iteration, for example, when I equals 1, we are going to raise 1 to the power of 2 and assign it to a variable called square. Okay, so in the first iteration, let me write it down here. The first iteration, I equals 1, and we are going to have 1 multiplied by 1, so the output is 1, and number 1 is assigned to a variable called square, and this is the assignment operator. In the next line, we are going to print this message. The square of 1 is, and we're going to print the value of the square variable which equals 1. So this is why we see it here. Square of 1 is 1. Okay. So we use the print function to have this part being printed in the output, and we use the paste function because we are having multiple strings and we would like to join them into one single string in the output. So square of 1 is 1. And then in the second iteration, I equals 2, therefore we are having 2 multiplied by 2, so the output is 4. So here when I equals 2, we are having number 4 as we calculated here being assigned to a variable called square, and in the next line we are printing this message: the square of 2 is 4. So square of 2 is 4. Then we go for the third iteration, which is this one. So I equals 3, so we are having 3 multiplied by 3, the output is 9. 9 is assigned to a square variable, so we see that square of 3 is 9. And then we are having the fourth iteration, I equals 4, so we have 4 multiplied by 4, so the output is 16. So we see that the square of 4 is 16. And finally, in the last iteration, we are going to have the I equals 5, meaning that 5 multiplied by 5, it's 25. So 25 is assigned to the variable square, and we are printing it here in the output. So square of 5 is 25. So in this video, we learned how to print the square of each number from 1 to 5. Thanks for watching. Hello everybody, and welcome to this video. In this video, we are going to demonstrate the use of break statement in a while loop. So here we are having one variable called I, and it is initialized to be 1. And we are having one while loop that the condition is true, meaning that it's an infinite while loop. And if we don't put a break statement, this condition will be always stay true because there is no condition actually there. This is just a true statement in parentheses. So when we are having the true statement in parentheses, we should have a break statement. Otherwise, it will become an infinite loop. Okay, so now I have the condition, the statement, the while loop statement or condition to be true all the time. And for certain situation, I'm going to put the break. So at some point, this program is going to be terminated. And first of all, what I'm going to do is that when we enter this while loop, first of all, I'm going to print the value of I in each iteration. Okay. And if I equals 3, I'm going to break, meaning that I'm going to terminate the while loop using the break statement. It's that simple. Otherwise, if this condition is not true, this part is not going to be executed and this line is executed. So the value of I is going to be incremented by 1 value. So let me illustrate it with more detail. So first iteration, I equals 1. Okay. So the condition is true. So we're going to enter the while loop. So we print value 1, which is here. You see it here. And we check 1 equals 3. No. So we are not going to enter this part. We're going to increment the value of I. So I now equals 2. Okay. So I now equals 2. So in the second iteration, we're going to have I equals 2. We're going to print 2 that we see here in the output. And then we check to see if 2 equals 3. Is it true? No. So this part is again not executed. We're going to increment the value of I. So I becomes 3. I equals 3 now. So then we are going to have the third iteration. So I equals 3. We're going to print the value of 3 here. And this loop is going to be continued. Why? Because the condition is always true. So we are going to have the print of I equals 3. So we see number 3 here in the output and we check this if condition. 3 equals 3. Yes, this time it's true. So we mentioned that if I equals 3, then break. Okay, meaning that exit the loop when I equals 3. So this break is executed. Therefore, this part of the code is not going to be done anymore. So this increment is not going to be done anymore, and the program is terminated. So this is why we are having 1, 2, 3 only in the output. So if I write down instead of 3 number 10 here, it means that we're going to print 1 to 10, but we're not going to have the number 11. Why? Because when we print the I equals 10 here, then 10 equals 10, this condition is met. We're going to break and we're going to exit the loop when I equals 10 now. And this part is never executed anymore to increment the value of I from 10 to 11. So now if I run the code, you see that the print of from 1 to 10 is being shown here in the output. Thanks for watching. Hello everybody and welcome to this video. In today's video, we are going to discuss while loops. We're going to write a program to calculate the sum of first 10 natural numbers using a while loop. So in order to use a while loop, first of all, we need to initialize our iterating variable, which is I, and it is initialized to be 1. And we are having a new variable called sum, and we are going to store the sum of the first natural numbers in this variable, and it is initialized to be 0 in the beginning, but we're going to update it in each iteration in our while loop. So here is my while loop. We're going to continue this while loop as long as I is less than or equal to 10. This is the condition of this while loop. And why this is the condition? The reason why is that we would like to calculate the sum of the first 10 natural numbers. If we wanted to have the calculation of the sum of the first 100 natural numbers, this condition should have been I less than or equal to 100 rather than 10. But this condition comes from the problem statement. Okay, so while I is less than or equal to 10, we're going to execute this part of the code. Okay, basically in each iteration, first of all, we are adding the value of I to the variable sum, and then we are going to increment the value of I by 1 unit. So let me illustrate it with an example. So in the first iteration, we're going to have I to be equal to 1, okay, meaning that sum equals sum plus 1, and sum is initialized to be 0 in the beginning. So the new value of sum is 1, sum equals 1, okay, and then we increment in this line the value of I. Okay, so the new value of I equals I plus 1, and I equals 1 plus 1, it will become, so I equals 2 now. Okay, so then we go for the second iteration. I equals 2. 2 is less than or equal to 10. Yes, so I equals 2. We're going to have sum equals 1 plus 2. Why? So this number 1 comes from the fact that we're going to have sum, the new value of sum equals sum plus I, okay? And the final version, the last version of the sum has the value of 1. So this is why we are having 1 here. And I equals 2 from the previous iteration, so we are having 2 here. So 1 plus 2, sum equals 3. And now I equals 3 as well, okay? So in the third iteration, I equals 3, sum equals 3 plus 3, so sum will become like 6, and I now will become 4, okay? So then we are having the fourth iteration where we are having I equals 4, so sum equals 6 plus 4, so sum equals 10, and I equals 5 this time. So this iteration is going to continue until we reach I equals 10. Then at that point, we are going to have the final value of sum, because in each iteration, the sum is being updated. So let me illustrate it with an example. In the first iteration, sum will become 1. Why? Because I equals 1. Okay, I equals 1, sum will become 1. In the second iteration, I equals 2 and sum will become 3, because 2 plus 1, which is the value of the previous iteration of sum, will become 3, because we are trying to have the calculation of the sum of the natural numbers from 1 to 10. So now we added 1 and 2. In the next iteration, I equals 3 here, as you see. Then we are having the new value of sum equals to 6, meaning that the previous value of sum, which was 3 in the previous iteration, plus the current value of I, which is number 3, it will become 6. So this way we are adding the values of I to a new variable called sum. So first of all, we are adding number 1. We store the value, then we add on number 2, then we add on number 3, then we add on number 4, and it is going to continue until the last iteration where we add on number 10 to the value of sum. So from number 1 to 10, the sum, when we run the code, will become number 55 following this logic. But if we want to do it with hand manually, it's very hard, but using this code, it's very easy now to even calculate the sum of numbers from 1 to 100. So when I run the code now, because I modified 10 to 100, it will become 5050, the sum of numbers from 1 to 100. Thanks for watching. Hello everybody and welcome to this video. In today's video, we're going to learn about while loops. So while loops are going to be used for different purposes. We can have loops like for loops, and we can have another type of loops that is while loops. Usually when we don't know how many times we're going to do the repetition, it's better to continue, better to implement actually the while loop. So now here I'm having an example here for you. I would like to write a program to have a countdown. So I would like to print numbers from 1 to 5. In order to do that, first of all, I need to initialize my iterating variable. So I is my iterating variable that is initialized to be 1 using this assignment operator. Okay. Then in order to actually implement a while loop, we are going to write down the while keyword, and inside parentheses we are going to write down the condition. So we would like to continue this while loop as long as I is less than or equal to 5. Okay, and when this condition is met, we are going to execute this part of the code actually. And whenever we are going to enter this while loop, first of all we are going to print I, and then we are going to increment the value of I by 1 unit. Let me illustrate it with an example. So here is my iterating variable I initialized to be 1 in the first iteration. So 1 is less than or equal to 5. Yes, it is true. So in the first iteration, first of all, in the first iteration, we are going to print 1. Okay, and then when I run the code, you see this output. So we are going to print 1, and in the next line we are going to increment the value of I by 1 unit. So I, it's like equals I plus 1. So I already is 1, and we are adding another 1 unit to it, so it will become 2, and 2 is assigned to be the new value of I. Okay, so we go up again, so we check this condition. Now I equals 2. 2 is less than or equal to 5. Yes, so we are going to, in the second iteration, we are going to have the print of number 2, and I equals I plus 1 again, and this time we are going to have 2 plus 1, which will be 3. So this part is finished. We go up for another iteration. 3 is less than 5. Yes, we are going to print 3, and then we are going to increment it by 1 unit, so it will become 4. and then 4 is less than 5, we are going to print 4, increment it by another 1 unit, it will become 5. 5 is less than or equal to 5, yes, so we are going to print 5. We are going to increment by 1 unit, we are going to increment it by 1 unit, so it will become 6. 6, is it less than 5? No, so this condition is not passed and the program is terminated. And when we look at the output, we are going to see I is 1, 2, 3, 4, and 5. We also could change this condition. For example, we could have I equals 5, for example, and we change this condition. So we would like to continue as long as I is greater than or equal to 0. And in each iteration, we are going to reduce 1 unit from I. This way, it means that we are going to start with I equals 5. 5 is greater than 0, yes. So we print 5, we reduce 1 unit, so it's 4. 4 is greater than 0, print 4, it will become 3. 3 is greater than 0, yes, so we print 3 and we are going to reduce it by another 1 unit. So it is going to continue as long as I equals until I equals 0. So this way we are going to have a countdown from 5 to 0. The previous example was to have a count up actually from 0 to 5. Now we are having a countdown from 5 to 0. So we see that here by changing some minor modification, by having some minor modification in the code, we can reach to a totally different program. Thanks for watching. Hello everybody and welcome to this video. In today's video, we are going to discuss about while loops in R programming language. So here we are going to discuss while loops. Before we discussed about the for loops. However, while loops are going to be... Hello everybody and welcome to this video. In today's video, we are going to write a program to print even numbers from 2 to 10 using a while loop. So in order to do that, first of all, we need to have the initialization of our iterating variable, which is I, and number 2 is assigned to it. So because we would like to have the print of even numbers from 2 to 10, this is why the starting point is 2, and we are going to assign number 2 to the variable I. Then we are having a while loop, and this is the condition of our while loop. So this while loop is going to continue until I is less than or equal to 10. Because the ending point is 10, this is why we are going to continue this while loop as long as I is less than or equal to 10. And then we are going to have this part of the code being executed when this condition is passed. Okay, so we are going to have the print of I in the first iteration. Then we are going to increment its value by 2 units. Why by 2 units? Because even numbers are going to be 2, 4, 6, 8, and 10. So there are differences between 2 even numbers that are 2, not 1. Because if we add 2 plus 1, if we add 1 plus 2, it will become 3, which is an odd number. It's not an even number. So in order to get another even number starting from number 2, we need to add 2 units in each iteration. Okay. So when I run this code, we see that 2, 4, 6, 8, and 10. These are the numbers that are being printed in the output. So these are the numbers that are being printed in the output that are even numbers from 2 to 10, as we expected. But how does it work? So let me illustrate it here with details. So in the first iteration, I equals 2, so we're going to print number 2, okay? And then increment the I variable by 2 units, so I will become 4. Then in the second iteration, we are going to have I equals 4. So we print 4, we increment it by 2 units, it will become 6. Then in the third iteration, we are going to have I equals 6. So we print the 6, and we're going to have I equals 8 now. Okay, we increment it by 2 units. So and finally in the last iteration, which is the fourth iteration, we're going to have I equals 8. So we print 8. Therefore I now equals 10. Okay, and sorry, it was not the last iteration. The fifth iteration is the last iteration. So the fifth iteration, we're going to have I equals 5. Then we're going to print number 10, increment the value of I by 2 units, so it will become 12. But we're not going to continue this while loop. Why? Because now I equals 12. So 12, is it less than 10? No, it's not going to pass this condition. So we're not going to have another iteration. Okay, so in this video, we learned how to have a while loop to print even numbers from 2 to 10. Thanks for watching.